Hello, everybody. I'm Nathan Turner. I'm the Vice President for Communications at the IMA, and I'm just very happy to welcome everybody to this Early Career Mathematician Seminar Series talk. This is part of the series that's celebrating 20 years of the Early Career Mathematicians Committee. And today we are joined by PhD student Holly Justice. So Holly is going to talk to us about mindsets, emotions, and goals in university mathematics students. So I think this will be a really interesting one. It's not something I've thought about very much since I was at university. So it'd be really interesting to hear from you, Holly. So I'll pass over to Holly if you're ready.
Yeah, thank you very much. I'm just going to share my slides. So can everyone see my slides?
I'm going to turn it off in a sec, just a minute.
Yes, all good. Holly, thank you.
Perfect. Okay, so thank you everyone for joining. My name's Holly Justice, and I'm going to be talking to you today about some of my PhD research, and that focuses on the mindsets, goals, and emotions in university math students. So, an introduction to the research and a bit about me. My background is that I'm a third year PhD student in maths education at the University of Nottingham, and I previously completed an integrated master's in maths at the University of Nottingham. My interests within my PhD are acknowledging the potential barriers and difficulties faced by students from different backgrounds when accessing maths education. And the overarching aim of the PhD project is to understand how we might be able to provide equitable access to maths education for all students. My motivations come partially from my own experiences. So I'm from the northeast of England. I'm also state school educated and I'm female. So I am kind of underrepresented in maths. So reflecting on my own experiences is really interesting to do. And also thinking about the experiences of others and working in sort of equity, diversity, and inclusion is really interesting. And rewarding to think that I might be able to help others. So the project background, first of all, so the overarching theme of the project is leaks in the maths pipeline. And the maths pipeline is kind of an analogy used to describe the flow of students from the earlier stages of maths education right the way through to, for example, university maths and PhD maths or into maths careers. And there's different ways of thinking about restrictions and blockages of flow through the maths pipeline. So the first one is restriction by eligibility, when the student's attainment is less than what they need in terms of entry requirements of the next stage of maths education. And this can lead to underrepresentation via differences in attainment by demographics. So, for example, we have the disadvantage gap in at school level and at A level. So, disadvantaged students attain the top grades at GCSE at a lower rate than their more affluent peers, and therefore are not eligible to progress to the next stage of maths education at the same rate as their more affluent peers. We also have, for example, awarding gaps at university by ethnicity. However, these are quite low in the mathematical sciences, but these awarding gaps could lead to underrepresentation in certain maths careers and potentially further studies such as master's degrees or PhDs in the mathematical sciences. Another way of thinking about underrepresentation is when people leave by choice. So they are eligible to progress to the next stage of maths education, but they don't necessarily want to. An example of this is the gender gap. So women who have the top grades at GCSE choose not to take A-level maths at a higher rate than men. We also have, for example, the attrition of Black, Asian, and minority ethnic students at university. So they prematurely drop out of their maths degrees, and that is not necessarily down to attainment. And an interesting thing, just to finish this off, is that we have when low socioeconomic status students, so disadvantaged students, achieve the grades to progress to the next stage of education, so from A level to university, they're actually more likely to choose maths at undergrad than their more affluent peers who are also eligible. So the summary and the point that I'm trying to make here is sometimes looking at restriction by attainment is important for some groups of students. So for example, disadvantaged students. But when looking at, for example, the gender gap, it's maybe more important to think about why these people might leave by choice. So why might people choose to leave? We have this perception of maths as a really difficult subject. And this is potentially perpetuated by teachers or peers who might have studied maths. And the paper that I've referenced there is titled, "I Would Rather Die, Reasons Given by 16-Year-Olds for Not Continuing Their Study of Mathematics." And that paper mentions that teachers might tell their students, there's no point in you taking A-level maths unless you get the absolute top grades in maths because you'll not do very well. So then you have this maths is too hard for me idea. We also have potentially the attitudes and mindsets in mathematics. So is the curriculum interesting for everyone? Is it actually useful to everyone? Yeah, who is it actually interesting to? So obviously we know that it is interesting to some people, but it might not be interesting to others. We also have a lack of subjectivity in maths. We have this idea that we're either right or wrong, and obviously maths is largely examined, so that might be off-putting to some people. So an example of where people choose to leave are women with PhDs, okay? So of course we have funding is a major constraint for progression to PhD level. And there's major competition for places. And of course, it is valid to actually want to just leave education and get a job after completing a degree. But this doesn't explain the drop-off in progression of females from completing a first degree to studying a doctorate in the mathematical sciences. So you can see in this figure, the proportion of females who have graduated from a first degree in the mathematical sciences is 36%. But the proportion who graduate from a doctorate degree is 30%. And the entry rate of females into PhD is also around 28.2%. So it's not just in terms of graduates as well. There is actively a drop in the proportion of females wanting to study a doctorate degree. So what might be happening? So I'm going to aim to answer sort of this overarching question. So what sort of learning environment is there in university maths? What are the mindsets and achievement related goals of students? What negative emotions are experienced by students both in class and while studying? How do students approach learning and studying maths? Is it how we expect? Do students enjoy university maths? Are all of these things related to each other? And what actually predicts attitudes towards further study? So a scenario, and I'm going to sort of introduce very slowly some technical jargon that I'm going to mention throughout the rest of the presentation, but I'm going to try and do this in an intuitive way. So I'm going to sort of talk about some potential thoughts that a student might have and then relate them to concepts in the literature. So here we go. The last thing I want is for anyone to think I'm not smart. Could indicate that the student has a performance avoidance achievement goal. If I mess up in front of this lecturer, I'll prove I'm not smart enough. So this is a potential failure situation which is subjectively harmful to the individual. What's the point in classes? I never seem to write anything down or get anything done. This suggests that the student is experiencing hopelessness after avoiding engagement with classes. My friends seem to get so much out of classes, but I don't enjoy them. I feel like I'm not doing university properly. So this could be low in-class enjoyment, potentially feeling shame, and this might also have an impact on the student's sense of belonging in maths. The important thing is my grade. I just need to apply what I know about studying. So this is potentially the student adopting safety learning behaviours, and that's potentially a surface strategic approach to studying. I'd much prefer to stay at home and catch up. I can learn the material by reading the notes anyway. So this is avoiding enriching experiences that they could, experience if they went into class and talked to other people, talked to lecturers. I think I understand, but I never ask for help. I don't know where I am. I wish I submitted that formative work. So this is the consequences of the students' avoidance behaviours, which is leading to uncertainty, potentially some anxiety, and also shame. I'm interested in this topic, but it's not on the syllabus. I can't devote my time to it. I'm more worried about the exam. So this is where the student is adopting a surface strategic approach to learning, and this is potentially leading to a lack of enjoyment because they can't explore their interests and their curiosities. And finally, I don't relate to academics or PhD students. I don't feel very immersed in mathematics. So this suggests a lack of sense of belonging and subsequently a low desire to remain in maths. So there's quite a few statements there, and as you can see, they kind of go round in a cycle. And if you could just think about like, have you heard students say these things? Do you relate to any of these from your own experience as math students, if you were math students? So now I'm going to talk about some connections in the literature, and just a warning, there is a lot of concepts here, and I'm not expecting you to take necessarily much from this slide, but I just wanted to sort of show you the vast sort of landscape of educational constructs that I've been looking at when trying to understand how the learning environment might be related to students' desire to remain in maths. So first of all, we have in the literature this connection between students' theories of intelligence and their achievement goals. So a theory of intelligence is what students believe about intelligence. So whether they think that it's fixed and you can't change it, or whether they think that intelligence can be changed and it can grow if you work hard. So if students have this more of this growth mindset, it leads to a mastery achievement goal, where the student is focused on learning new knowledge and new skills. Whereas if a student has a more of a fixed theory of intelligence, they're more focused on showcasing that intelligence that they do have, and they have what's called a performance goal. So a mastery goal is said to be an adaptive goal, because it means that students will embrace challenge, and they're not too bothered about showcasing their intelligence, and therefore they will do well because they're putting in the work. Whereas with a performance goal, students tend to prefer to do things that are easy for them, and they don't necessarily embrace challenge. So that leads to poorer attainment. However, within the literature, there are some suggestions that under certain circumstances, a performance avoidance goal can actually be protective of attainment. So, for example, for women under stereotype threat, a performance avoidance goal can be protective of their maths achievement. We also have these things linked to sense of belonging in maths, and then subsequently desire to remain in maths. And sense of belonging has become kind of a buzzword in higher education because we know how important it is for students to feel comfortable and safe and want to remain in higher education. And then we have all of these other concepts, so like self-efficacy, learning behaviors, achievement emotions, approaches to learning and studying, activity emotions. So you can see there's such a vast landscape of concepts. And I've read lots of literature about these things, and I've considered them before thinking about what to investigate. So one thing I'm going to explain is the control value theory. So I have done this in sort of pseudocode to sort of appeal to the mathematicians. I don't know whether this will work though. So if a person perceives that failure is likely and that failure is subjectively harmful, and if control is low, so they can't necessarily do much to change the fact that they're going to fail, then they will experience a negative achievement emotion of hopelessness. If instead they are uncertain about how much control they have over the situation, then they will experience anxiety. Otherwise, if they perceive that they have quite a high level of control, then they'll experience relief. But if in the first place they didn't perceive failure was likely, or if failure was not subjectively harmful, then they wouldn't experience any negative emotions. So an example of this is preparing for an assessment. So of course, that's a potential failure situation if they believe that they might fail the assessment. And failure is subjectively harmful because if you perform poorly on an assessment, then it means that your classification is going to suffer from it. And the perceived level of control you have over that through potentially having revision resources or being able to speak to lecturers or something like that can impact the negative emotions you might experience. So I have a hypothesis about failure situations for a certain type of student. So what might constitute a potential failure situation that is subjectively harmful to the individual? Thinking back to a performance avoidance goal, so just to recap what that is, it's the goal to avoid being the worst and to avoid being a failure or being perceived as a failure. With a performance avoidance goal, there's always a potential for failure. So, for example, interactions in class, talking to a lecturer, having a discussion with a postgraduate student about maths. There's always a potential for failure because you could always say something wrong. And it's always subjectively harmful because the goal is to avoid being perceived as a failure and avoid being perceived as not smart. And the perceived level of control of the situation might depend on the student's self-efficacy and also their intolerance of uncertainty. So what I mean by self-efficacy is how confident a student is that they are able to work it out or work with the material and be able to do something about it. And also intolerance of uncertainty could lead to, at what point does the person consider themselves likely to succeed? So the aftermath. So after experiencing a failure situation and experiencing these negative achievement emotions of anxiety and hopelessness, this could lead to safety behaviors. So what I mean by safety behaviors in this context is potentially rote learning, memorization, studying past papers, so like looking at the mark schemes and applying that when they sit their own exams, potentially avoiding extracurricular maths or even just extracurricular activities like sports just to make sure that they have enough time to revise, etc. Potentially avoiding classes or not properly engaging in classes. And this sounds like the surface strategic approach to studying, where a student is more concerned with doing what they need to do to pass or to succeed than they are concerned about understanding the material. So a misalignment of in-class activities, so the activities that a student does in class with their approach to studying, so in this instance, a surface strategic approach to studying, could lead to a lack of enjoyment of classes. And when a student compares their own studying behaviours, particularly their safety behaviours, and their lack of enjoyment and the fact that they're not pursuing their own interests with other students on their course, they might start to think, oh, well, I'm not good at maths, I'm just good at passing exams. And some people seem to be getting much more immersed in the maths than me. And that might lead to a lack of sense of belonging in maths, and then a subsequent lack of desire to complete a PhD. So when considering what exactly to investigate, so this is the larger concept map, and this includes um, everything I've just spoken about in terms of the hypothesis about the failure situations, and the emotions and the approaches to studying, and also the connections in the literature. So obviously, I don't expect you to be able to look at this and take anything from it, but I am going to explain in terms of the concept what I am investigating. So first of all, I'm investigating the link between achievement goals and control value theory. Um, and I'm also considering separately the in-class situation versus the general situation. So what I mean by general is generally whilst the student is studying. I'm also considering self-efficacy as a potential moderator for the relationship between achievement goals and in-class achievement emotions. And I'm considering intolerance of uncertainty as a predictor for in-class achievement emotions. Finally, I'm considering how emotions might predict students' desire to remain in maths, particularly in the undergraduate to PhD pipeline. So to do this, I designed a survey, and this was for second and third year university maths students in England. And the way I rolled this out was I asked some connections at a few universities to invite their students to take part via emails and through lectures. So I measured the following concepts. Again, you don't need to read too much into this, but these are loosely defined as mindsets, goals, and emotions. I also put some statements in there that measured students' desire to remain in maths. And the main one I'll be considering is the one about PhD maths. So I would consider completing a PhD in mathematics or a closely related area. I also measured students' self-reported attainment from the previous academic year and some demographic information such as gender, ethnicity, parental education, things like that. So again, these concepts can be loosely defined as mindsets, goals, and emotions. And when I refer later in the presentation to PhD consideration, I'm talking about this statement. I would consider completing a PhD in mathematics or a closely related area. Oh, and also just to note, again, when I refer to general emotions, I mean generally whilst studying maths at university and not generally in life. So the responses I got from the survey, I got 210 responses from 12 universities in England. Obviously, that's a relatively small sample size, and there will be issues with missing this not at random. And of course, we're going to have, potentially more responses from the more engaged students and maybe not as many responses from less engaged students. In terms of the universities that they came from, 8 were Russell Group and 4 were non-Russell Group. In terms of proportions by demographics, it was relatively fine, but some things to point out were the small number of ethnic minority participants, and because this is small, we can't necessarily say anything about ethnic minority students, which is unfortunate. But we also had, interestingly, quite a large proportion of participants in the sample considering themselves to have a mental health condition. And I'm not too sure whether this is just the way it is, or whether we had quite a high level just in our sample, but just something to note. So, what are the mindsets and achievement related goals of our students? So first of all, I'll just talk about the scale. So we asked students to indicate their agreement with several statements that were related to the constructs. So for example, for fixed mindset, there were a few items, and they had to indicate whether they strongly disagreed or agreed or anything in between with those statements. And we took an average of the items, and then the score that you see on the graph is the mean score of those items. So for example, with fixed mindset, if a participant has a score of 1, that indicates that they are strongly inclined against a fixed mindset. And in fact, they are, in this instance, inclined towards a growth mindset. So you can see for our participants, they tend to favor a growth mindset over a fixed mindset on average. Now looking at achievement goals, so we have mastery, performance approach, and performance avoidance. So mastery is, I think I've said this, but where students have a goal to learn new things above all else. And the performance approach goal is where I'm not sure what's happened to someone drawn on my screen. If you could stop doing that, I would appreciate it.
Yeah, it looks like maybe somebody on an iPhone. If you're using an iPhone to watch, then yeah, if you can make sure you're not accidentally drawing on the screen.
Well, yeah, so a performance approach achievement goal is loosely defined as when a student wants to outperform others. And the majority of our participants were actually inclined against this goal. And for performance avoidance, which I'll define again as the goal of students to avoid failure or to avoid being the worst. And that was a bit more of a mixed bag in terms of responses to that. So we had students, some inclined towards it, some neutral, some inclined against it. And also just to mention that these achievement goals are not mutually exclusive, so you can have combinations. And the most common achievement goal profile was a mastery only profile. And the second was actually a combination of all 3 goals together. And the third was a combination of mastery and performance avoidance. So, which negative achievement emotions are experienced? So, just a reminder, we measured anxiety, shame, and hopelessness, and we measured those in class and generally, but generally means generally while studying. And the most interesting thing here is the difference between in-class anxiety and general anxiety of our participants. So on average, in-class anxiety was lower compared to general studying anxiety. So maybe students feel more at ease in the in-class situation than when they're dealing with the material on their own. In terms of in-class shame, general shame, and an in-class hopelessness and general hopelessness, it's kind of what you would expect. The majority of participants didn't experience hopelessness or shame. But for in-class shame, it appears to have a bit of a bimodal distribution, with some students not experiencing in-class shame, but quite a few students experiencing it. So, how do students approach learning and studying maths, and is it how we expect? So, we measured the deep strategic approach to studying and the surface strategic approach to studying. And the deep strategic approach is where students are primarily concerned with understanding the material, whereas the surface strategic approach to studying is where students aren't necessarily concerned with understanding the material. They're more concerned about doing what they need to do in order to pass the exam or succeed in whatever they're wanting to do. And just to note as well that this was measured in terms of frequency. So a 1 on this scale corresponds to students never use this approach, whereas a 5 corresponds to students always use this approach. So notable features, participants seem to use the surface strategy more often than they use the deep strategy, which is relatively interesting because considering this is a sample of university math students. And also we have very few participants saying that they use the deep strategy, often or always, which is quite interesting. So do students enjoy university maths? So we measured general enjoyment, and we also measured in-class enjoyment. And it seems like on average, general enjoyment is actually higher than in-class enjoyment, which is quite interesting. We also have few participants saying that they really enjoy the in-class maths. So are all of these things related? What actually predicts attitudes towards further study? So what I've done to investigate this is I've used path analysis. So path analysis is kind of like regression, but instead of just exploring the relationship between one sort of predicted variable and multiple predictor variables, we're looking at like multiple relationships between multiple variables all at once. So to do this, I used the Lavaan package in R to fit the model according to everything that I've just mentioned. So the hypotheses that I've talked about in previous slides. And then I refined the overall model by removing predictors which weren't significant. And I also moved some predictors to elsewhere in the model where it was theoretically justifiable. But because I've done this refinement process, the analysis is somewhat exploratory. And it means that I can't necessarily draw conclusions about causal inference, which is something that path analysis tends to be used for. And just to note as well that because of the sample size, I couldn't fit the whole model at once because there would be too many parameters. So what I've done is I've split it up into piecewise models with overlap, so we can still say something about the entire model without estimating too many parameters. So this is piecewise model 1. And just before I start, I don't expect you to sort of take all of this in. The main thing is that we fitted a model based on the theory that we've mentioned in terms of the hypotheses that were talked about before. And there was enough support for it, so the model fit was good. So in terms of R-squared values, so the variance explained for in-class enjoyment was relatively high, but for the other variables, PhD consideration, deep strategy, and surface strategy, this was less well explained, but we're not necessarily looking for really high variance explanation. We're just kind of looking for an indication that this is somewhat explained. So piecewise model 2, again, I am going to go through the conclusions of this afterwards, so don't try and spend too much time trying to figure out what's going on here. But this also had good model fit. And you can see, so in the previous model, I'll just go back, we had on the right-hand side, we had this connection to sort of desire to remain, so PhD consideration. But in piecewise model 2, we've removed that at the top end, and instead, on the left-hand side of the model, we've added in things like fixed mindset, gender, ethnicity, and intolerance of uncertainty to predict achievement goals. So again, the R-squared values, so for the variables that were also in the previous model, the R-squared values are relatively similar. In-class hopelessness in this model was predicted relatively well, and performance avoidance was predicted it was predicted okay. So key conclusions and discussion. So first of all, I'll talk about PhD progression, so consideration to study a PhD of these students. So first of all, in-class enjoyment was a positive predictor of the consideration to study PhD. But we thought also that general enjoyment, general boredom, and in-class boredom would also be predictors, but they aren't, or they weren't significant in the model. We also have that the deep strategic approach to studying was a positive predictor of PhD consideration. And we also controlled for prior attainment and math self-efficacy because we assumed that they would be predictors of whether someone was considering to study a PhD, aside from the learning environment. So why is this important? Well, we saw in previous slides that in our sample, in-class enjoyment is lower than general enjoyment on average. But if in-class enjoyment is a positive predictor of PhD consideration, then do we need to pay attention to the learning environment and encouraging different teaching practices potentially to make sure our students are enjoying the learning environment? So on to achievement emotions. We imagined that both hopelessness in class and anxiety in class would predict surface strategy and in-class enjoyment. But it turned out that only hopelessness in class predicted these things. But this might be because anxiety and hopelessness are strongly positively correlated. So why is this important? So this aligns with the theory that in-class negative achievement emotions lead to sort of rote learning, potentially surface strategy, and the misalignment of learning approaches with the in-class activities could lead to a lack of enjoyment. So now on to achievement goals. So a performance avoidance goal positively predicts hopelessness in class and the surface strategic approach to studying. Whereas a mastery goal negatively predicts those things, and it positively predicts the deep strategy, so the opposite of surface strategy, and in-class enjoyment. Based on the literature, we also thought that performance avoidance goals would primarily be predicted by a fixed mindset. But it turns out that intolerance of uncertainty and demographics also predict performance avoidance goals. And why is this interesting? This could be a potential insight into the differences by demographics when choosing to complete a PhD, because we have that, first of all, demographics predict performance avoidance goals, which then positively predict negative achievement emotions such as anxiety and hopelessness, as well as surface strategy, which then negatively predict in-class enjoyment, but then in-class enjoyment positively predicts PhD consideration. So in terms of further work, fit in the model showed, moderate support for the theory, so I don't have to worry about discarding it. I would like to carry out some more survey work to include sense of belonging in maths, because I have mentioned that throughout, but it's a 30 question survey, so it's difficult to include directly in surveys to students. I would also like to do some interviews to pick apart the association. So, for example, does the control value cycle actually work how we think it works? And does in-class enjoyment actually directly influence sense of belonging in maths? So thank you very much. I'll now take any questions, and please be nice.
Thank you, Holly. That was really interesting. That's not something I've seen a lot of before, and it was really interesting to see how you kind of structured the problem, and link that in with the sort of quantitative feedback survey. the feedback from your survey. So that was fantastic. I have a quick question, if you don't mind, before we open the floor to everybody, which was in terms of, you mentioned that I think you said you had 8 different universities.
Yeah, 12 and
12.
yeah, 12 universities, yeah.
And I was wondering if you'd done any analysis per sort of per university, or whether you'd done it in any brackets, in terms of university ranking or anything, just to see if there was any difference in the models between the different universities.
Well, so the issue was that the sample size was really small. So in terms of fitting models, I was trying to use all of my data in order to sort of get those parameter estimates. But it is something that I could consider doing. Yeah, something I'll take away and try and do potentially with a bigger survey.
Yeah, I figured with the sample size you might have some challenges, but potentially in the future it could be something to look at. Yeah, great stuff. Edward, you've got a question.
Oh, thank you very much. Very interesting talk. I have a question about sample size, actually. So, have you considered what sample size would be good if you could recruit as many students as you wanted?
Sorry, say that again.
So, have you looked into what sample size would be ideal if you could recruit as many students as you wanted?
Well, to sort of to fit the type of model, I think I would probably need at least 500 students. That was what I was actually aiming for in the beginning, because so the what is classed as good practice is you need at least 10 responses per parameter that you estimate. And in a more ideal world, you want at least 20 per parameter that you estimate. So I aimed for at least 500. But unfortunately, trying to get students to take part in surveys,
I know.
yeah.
Thank you.
Thanks, Edward. A good question. And James, you've got a question as well.
Hi, Holly. Thanks for the talk, and sorry I'm late, which is just my normal behavior, it seems now. Quickly, just to want to extend thanks on behalf of the ECM committee for doing this, and talking about your ongoing research and putting your neck out there to share with us these results. I think I found it extremely interesting, as I'm sure both Nathan and Edward agree. I've got like 8 questions. So I will just use up the time unless anyone else steps in. But my first question, again, was about the sample. And thinking from like my own experience with sampling and like doing surveys with students, your observation about it's likely the better students reply is probably quite astute. How would you incorporate that? Like, because it's a bias. So have you thought about how you might incorporate that in your results?
Yeah, well, I think in short, I think it's just like acknowledging that we are potentially missing out results from less engaged students. But I think because of the sort of nature of the fact I'm looking at why might high attaining students not actually want to study a PhD. So I think, yes, I'm not getting necessarily responses from those students who might be less engaged and potentially lower attaining. Not saying that those things are necessarily always mean the same, but I think that because I'm trying to get information about those high attaining engaged students, I think it's just specifically saying this is the sample and this is who I'm likely to get, and this is the conclusions I can draw from that. So I think, yeah, does that kind of make sense?
Yeah, that's completely fair enough. I mean, that's a really good response, actually. Like, if we're being practical, our lower attaining students are not likely to want to go for a PhD anyway. So the fact that they're missed off the survey is maybe not as harmful as one might think on the surface. Question 2 out of 8. So when you were talking again, I was thinking about the students that I have now, and a lot of them come to university already with maths anxiety. So have you thought about, well, one, could you control for how the students arrive? Because if they already arrive only knowing surface level understanding and like that surface level methods, are they, how receptive are they to doing deep level learning? But also, could you compare, say, the students' attitudes at the beginning of term one when they arrive, and then at the end of term one, once they've seen how university mathematics is, do you think there would be a change there in terms of like, anxiety levels and in-class enjoyment and general enjoyment?
Well, I actually think that a lot of the surface level learning is a product of the English school system. So I do think that the way in which students learn at GCSE and A level directly leads into how they approach university. And I think it would be interesting to see if university can actually change that in some students and under what circumstances. But I do believe that largely the approaches to learning that students attack university maths with are the same as what they learn at A level, because in essence they're examined in the same sort of way. They might have some coursework. I'm assuming sort of that this is similar across most at least Russell Group universities. But yeah, I think that they kind of they learn these unhelpful behaviors and then they continue them through. But yeah, I would love to be able to potentially after my PhD, if I had more time, see how these carry from A level and GCSE through to university.
Yeah, I agree. I think it's definitely a product of the education system. And I mean, at Sussex, our grade is like 80% exam. So, with such minimal amounts of percentage of your grade on coursework, why change? Just
Yeah.
slam in those past papers and hope for the best. Like, totally get that. And particularly when, your top grade is 70%, it really motivates you to do that surface level. Like if all I've got to do is nail that past paper, I'm going to do well. I don't need to worry about the deep level and then having to handle all those issues that you mentioned.
Yeah, exactly.
So just following on from that, like we as university lecturers and even university students, we don't have the ability to change the school system. So how would you like to see your work used? Like, would you like universities to use it to say we should be adjusting our in-class like methods, or would you actually like it to be seen by secondary school teachers to say, actually, we need to look at this deep level learning? Like, what would you like your work to be used by?
I think it's really difficult, obviously, because you can't just say to, you can't just say to the government, this is what you need to change about the school system, because it's such a complex um situation, especially when like the idea is that schools need to be held accountable, and that's why we've got exams and we've only got a finite amount of resources, so we can't do coursework and things like that. So I think it's a really difficult thing to try and get secondary schools to try and do, particularly when they might argue as well that not everyone goes on to university to study maths and that's not a priority. But I think it's really important just to acknowledge that these are the experiences of students. And potentially there might be just individual support. And if students acknowledge that this is the way that they might be feeling and understand, oh, well, what I'm experiencing is I have a fixed mindset because my teacher has told me that I'm gifted. And therefore I have a performance avoidance goal because I need to showcase to everyone that I'm smart enough to be here. Um, if they understand what they're experiencing, maybe when it comes to applying for PhDs, they might think, actually, reflecting on this, I might be smart enough to do a PhD because it's different circumstances. I'm not just necessarily cramming for my exams because a PhD is not examined from 0 to 100. It's, a process. So yeah, I think in summary, it's more about acknowledging the potential experiences of students and maybe letting students know what they might experience.
Yeah, I was at a seminar fairly recently. I think it was a Talmo seminar, and it was all about some Scottish universities starting to include transitional courses between A-level and university. And I do something similar at Sussex. And the main focus was focusing on helping the students learn how to read and write maths appropriately. And I think they're missing something here, which is what you've highlighted, which is actually you should probably incorporate something about confidence and about anxiety and imposter syndrome and these things to actually really understand, to let the students know that there is the support and things like that. So yeah, this is it's good. This will be my final question, I promise. Well, I've got more, of course, but just how much of the results did you expect? Like honestly, like were there anything that was really surprising to you, or was this mostly like this is reaffirming your current beliefs of what is happening?
So yeah, there was actually something really unexpected. So bear in mind, I also did a pilot study, which I didn't include because the talk was 45 minutes and I didn't want to like add so much stuff in. But um, so in that talk, not in that talk, in that survey as well as this survey, I didn't see as much of a link between fixed mindset and achievement goals. So I think I mentioned in the talk that so there's a whole load of literature by someone called Carol Dweck, and she looks at the direct influence of having a growth mindset on your achievement goals. And there just wasn't a link for my sample in both cases. Obviously, there's maybe a very small link, but actually other things predicted it better. So I found that really interesting because maybe in the general population, it's the case that this link is there, but in our university math students, maybe students' sort of self theories of intelligence don't necessarily predict their achievement goals, or maybe we're not actually measuring their real theories of intelligence. Maybe we need to look at like how they perceive other people, like what they think other people think about intelligence, if that makes sense.
Yeah. Ah, cool. I will stop there as I see the time, so I'll let you off the hook for now.
That's great. Thank you, Holly, for answering those. Does anyone have any final questions in the last couple of minutes for Holly? Okay. So yeah, I'll just take the opportunity to say thank you again, Holly. That was really interesting and a very different talk to what I've seen in the past. There's a couple of things I'll follow up with you on actually that might be of interest. I'll drop you a message afterwards, or if you're okay to stay on the call for 5 minutes.
Yeah, definitely.
Thank you. So yeah, any final thoughts from anybody?
No, just thank you again.
Yeah, thanks, Holly. Fantastic.
Thank you for having me.
Thanks, everybody.